right, so today we're going to talk about two-way tables. Before we talk about two-way tables, we're going to look at just a table in general. So for number 1 here, it says, on an upcoming field trip day at school, the principal wants to provide ice cream during lunch. The principal offers 3 flavors, chocolate, strawberry, and vanilla. The results of surveying one class are in the table below. So as you can see, like they talked about in the description, there's 3 ice cream flavors. Chocolate, strawberry, and vanilla are the 3 flavors. And then this is the total number of votes. So it looks like they surveyed 25 students. So that total is important. It's how many kids were talked to and asked, what kind of ice cream do you want? Chocolate, strawberry, or vanilla? So we have our flavors and we have our total. So there's some questions here based on this table for us to answer. So which ice cream flavor do most students in this class prefer? So if I look at that, out of 25 kids total, 11 is the strongest, so we would say the favorite ice cream flavor is chocolate. Followed closely by vanilla, but chocolate definitely wins. Which ice cream flavor do the fewest students prefer? So that would be strawberry. So if Mr. Frank was going to go buy some ice cream, he's probably not going to go get strawberry. He's more likely to get chocolate, and maybe chocolate and vanilla, but probably not strawberry. What percentage of the students prefer vanilla? So vanilla, the fraction for vanilla would be 10 students out of 25. Our job is to turn that into a percentage. And there's a couple ways we can do that. You know that percents are out of 100, so I could take that and write it out of 100. And I know 25 times 4 is 100. So then 10 times 4 would be 40 out of 100, which would be 40%. Option number 2, we could have used the calculator here. I can take that 10/25 that we started with. So 10 divided by 25, because that's what the fraction bar is. The calculator will give me a decimal, and then I multiply that decimal times 100, and I still get 40%. What is the relative frequency? What is the relative frequency, that's a new vocab word, of students that prefer chocolate? All right, well, the fraction of students that prefer chocolate would be 11 out of 25. So relative frequency means give me the fraction, but rewrite it as a decimal. So all I have to do here is on my calculator, and I would take 11 students divided by, or out of 25, I get 44 hundredths. So the relative frequency would make that 44 hundredths. So relative frequency just means take the probability of the fraction and turn it into a decimal. So that's what we call a univariate categorical data. There was one piece of information we got from students. What kind of ice cream do you want? Right? The prefix UNI means one. There's one variant, or think about variable. So there's one piece of information, because data is about information. So univariate categorical data, there's one piece of information. Bivariate categorical data, well, the prefix BI, that means 2. So now there's 2 variables. So we're going to look at bivariate categorical data, or two-way tables here. So we're going to look at 2 pieces of information. So the table is going to get a little bit more complicated. But if we look at how it's organized, it's not so complicated. All right, so today's focus is going to be looking at two-way tables, but as you can see, if we glance at this table before we even read the description, there's pieces of information. So it's not only being able to read the tables, but fill in the information. So number 2 says 56 students were asked about their eye color and what their favorite hobby was. There's a lot of information there. There's 56 kids total. In the last one, the principal talked to 25 students. Out of 56 students were asked about their eye color, that's one piece of information, and their favorite hobby, that's a second piece of information. So this is going to be bivariate data, 2 pieces of information, specifically the eye color and their favorite hobby. The data collected was started in the two-way table below. We need to complete the table. So if I look at this, those 2 pieces of information, where do I see them? Well, here's the eye colors. The choices are brown, blue, and green. And then their favorite hobby, it looks like the choices are watching TV, playing sports, or talking with friends. Those are the 2 pieces of information they collected. So if I look at this table, this 9 represents that 9 students total said that they have brown eyes and they like watching TV. These 16 students, they also like watching TV, but they have blue eyes. But then there's also, we want to look at these totals. There's totals at the bottom. So I know that there's 17 total students that said their favorite hobby was talking with their friends. I know that 13 of the students that they talked to, they preferred playing sports as their favorite hobby. But there's a second total over here on the side. These are the totals for the eye colors. There's 20 total students that have a brown eye color. There are 5 total students that have an eye color of green. We still don't right now. We'll figure it out with the total number of students that have blue eyes. Now notice the total shows up both here, the totals total and the totals total. That is the number of students that they talked to all together. So this is a piece of information that they gave us in the problem, but not in the table. So we're going to add that in. We're going to say, let's see, I'll switch my color here. 56 total students. So everything in here is supposed to add up to 56. So there's lots of different starting points here. I'm just going to go along this first row. Brown eye color. There's 20 total students that have brown eye color. Well, I know this 9 and this 4 plus something is supposed to be 20. So, well, what can I do? Well, I'm going to go to my calculator. There's 20 total. I'm going to take away the 4 brown eyes that play sports. And then I'm going to take away these 9 brown eyes that watch TV. And I'm left with 7. That means 7 of the brown-eyed people are talking to their friends. So if I want to check that, remember how it's supposed to be 20? 9 plus 4 plus 7 gets me 20. All right, well, same thing down here at the bottom. Green's total is 5. I probably don't need my calculator here. 1 plus 2, that's 3. What does 3 need to make it to 5? 3 needs 2 more. So if I take 1 plus 2, that's 3. 2 more is 4, 5. So 5 of the green total. 2 of those 5 people that are green eyes like playing sports. Hey, now that I know that number, I can figure out this number right here. 4 plus something plus 2 is supposed to be 13. So if 13 people total play sports, can I figure out how many of those 13 are blue-eyed that like to play sports for their favorite hobby? So I'm going to start with the total again of 13. Let's take out the 2 that are green eyes, and then take out the 4 that are brown eyes. I'm left with 7. So if I plug in 7, I can check, is 4 plus 7 plus 2, that equals the 13 total. And then my last 2 pieces are just some totals, but now all my numbers are in here, so I can look at this. 9 plus 1 is 10. 10 plus 16 is 26. And then if I add 16 plus 7 plus 8, I can get the total number of blue-eyed students that were talked to. So that would be 31. So here's my final check to make sure that I have all my numbers correct. Because sometimes I type things in the calculator wrong. I want to make sure. This total should add up to 56, and this total should add up to 56, right? All the hobbies should be 56 total students. If I look at the eye colored, it should be the 56 students. So my last final check to make sure I plugged in my table right, I'm going to add the total 26, the 13, and the 17. I got 56. Those numbers are good. All right, and let's do it one more time. We'll go across the side here. 20 plus 31 plus 5. And I got 56. So I got this table is correct. So let's go to number 3 and try this one out. So it says that 100 students visited the YMCA over 3 days. So again, here's an important piece of information. With this 100 students visited the YMCA. The two-way table shows some information about these students. Complete the table. So where should that 100 be showing up? And if it's not there, we're going to put it there. That's right. It's the total number. So the total is going to go right here. So there's 100 students altogether that they talked to. All right. Well, what do we know? So there were boys and girls. They noted what gender they were. And then they also looked at days of the week. They went on Monday, Wednesday, or Friday. So if I look at this, the first thing I'm drawn to is that 43 boys plus all the girls was supposed to equal 100. So think about how would you figure out how many girls went? Yeah, you would take the 100 total students, take out the 43 boys, and we're left with 57. So this must be 57 in here. So this total adds up to 100. So the same thing should happen with these totals. 34 plus 30 plus something should also equal 100. Well, again, if I start with the total, let's take out the 30 that went on Friday, and then we'll take out the 34 that went on Wednesday. That leaves 36 that went on Monday. And if I want to double check my numbers, 36 plus 34 plus 30. We got 100. Now we can go back and fill in the rest of the table. So on Monday, 36 students went to the YMCA. 21 of those students were girls. What's left to be boys? So 36 total. Take away the 21 girls. That's 15 boys. So right here, I don't have enough info to figure out those two numbers, but I can go over here. 30, take away the 16 that are boys. How many girls went to the YMCA on Friday? So 30, take away the 16 of those 30 that were boys. That leaves 14 for the girls. All right, so I can't go this way to figure out Wednesday, but I can go across. There are 43 total boys. 15 went on Monday and 16 went on Friday. What does that leave for Wednesday? So if I take the 43 total, let's take out Monday's 15, and then take out Friday's 16. That leaves me with 12 for Wednesday. And same thing with the girls. If there's 57 total girls, and I take out the 21 that went on Monday, and then take out the 14 that went on Friday, that leaves 22 girls that went on Wednesday. And if I want to check those numbers, 12 and 22 should make that 34. And again, I encourage you to pause, try the next one out before you unpause it and check to see my work. All right, so hopefully at this point you've paused the video and you tried this table yourself. So I'm going to go a little bit faster through this one. So we have the diagram below shows how many 7th and 8th graders are right or left-handed. So here's my two pieces of information. What grade level are you? And are you right or left-handed? So they didn't tell me up here how many students that they talked to. So if I go to the table, how many students did they talk to? That's right, there's 70 total students altogether. So again, there's many different ways to start this table and fill it in. The idea is to get all the pieces filled in correctly. So it's okay if you didn't start where I started, as long as your numbers match. So I'm going to start like I did the last one. There's 35 7th graders. How many 8th graders to make 70 total? So I'm going to take the 70 total, take out the 35 that are 7th graders. That means there was also 35 8th graders. And then same thing along the bottom. Of the 70 students, if I take out the 29 that are left-handed, that leaves 41 right-handed students. All right, well, if there's 41 right-handed students and 23 of them are 8th graders, what's left to be the 7th graders? So if I take 41 total, take out the part that is 8th graders, that leaves me with 18 right-handed 7th graders. And then this piece right here, there's 29 total students. There are 29 total left-handed students. If I take out the 17 that are 7th graders, that leaves me with 12 8th graders that are left-handed. Because if I take 17 and 12 and add those together, here's my little check, that's the 29 total. So my totals should add up to 70, but then each column and each row should add up to their totals. And that is it for today. You are set with this part of the lesson.